Is your computer feeling sluggish, like it's wading through molasses when it should be sprinting? When that familiar lag creeps in, what's the first thing you instinctively blame? For most, it's the processor, that seemingly mighty engine at the heart of your machine. We envision it struggling, groaning under the weight of demanding tasks, and conclude that a faster CPU is the only solution. But what if I told you that this common assumption is often a red herring, diverting your attention from the real bottlenecks that might be holding your entire system hostage? Imagine your computer not as a single powerful entity, but as a meticulously orchestrated ecosystem, where every part, no matter how seemingly minor, plays a crucial role. This video is about dismantling that simplistic view and revealing the unsung heroes that truly dictate performance. We're going to explore how the foundation upon which everything else is built, the motherboard, acts as the central nervous system, dictating not just what components can even talk to each other, but how efficiently they can exchange information. Think of it as the intricate road network of a bustling city. A poorly designed or congested network will cripple even the fastest vehicles. We'll venture beyond the obvious and delve into specialized components that, while not always the spotlight stealers, can dramatically transform your experience, turning casual hobbies into professional endeavors and elevating everyday audio to an immersive art form. Get ready to have your perceptions challenged and your understanding of digital performance fundamentally reshaped. In our daily lives, sophisticated tools permeate every aspect, from working from afar to digital pastimes. Yet, all too often, we encounter the vexing reality of a sluggish system, one that simply cannot keep pace with our growing needs. Comprehending how the various internal elements of a personal computing device interact is paramount for maximizing efficiency and preventing wasteful expenditures. It's not solely about possessing the most robust physical components, but about ensuring each part operates harmoniously to deliver the finest possible user experience. We will now embark on an exploration of performance enhancement, unraveling the enigmas behind operational speed and demonstrating how you can transform your device into a veritable powerhouse. We'll venture beyond the obvious and delve into specialized components that, while not always the spotlight stealers, can dramatically transform your experience, turning casual hobbies into professional endeavors and elevating everyday audio to an immersive art form. Get ready to have your perceptions challenged and your understanding of digital performance fundamentally reshaped. Beyond the primary processing units and visual output devices, a hidden world of specialized hardware exists, each contributing its unique prowess to the overall operation. Consider, for instance, the often overlooked sound processing unit. This component is not merely responsible for playing back music or system alerts. It's the orchestrator of intricate audio landscapes, capable of rendering nuanced sound effects for games, delivering crisp, studio-quality audio for content creation, or faithfully reproducing the subtle dynamics of a classical symphony. Its ability to interpret and generate complex sound waves directly impacts the immersion and realism of any audiovisual experience, making it a critical, albeit often unacknowledged, player in the performance equation. Similarly, the infrastructure that facilitates rapid data exchange between these various internal parts plays a pivotal role. This underlying network, often referred to as the system bus, acts as the central nervous system, dictating how quickly information can travel from one component to another. A bottleneck here can severely hamper the performance of even the most powerful individual parts, akin to having a superfast car with a narrow, congested road to drive on. Understanding the bandwidth and speed of this interconnectivity is key to unlocking the full potential of the entire system, ensuring that every command is executed without delay and that data flows freely, enabling seamless multitasking and instantaneous responsiveness. At the core of every computing system lies a pivotal component, the central nexus that orchestrates the symphony of operations. This vital element serves as the foundational platform, meticulously designed to house and facilitate communication between all the other functional units that comprise a personal computer. Its design dictates precisely which other parts can be connected, acting as an intelligent gatekeeper that ensures compatibility and prevents the integration of mismatched hardware. More than just a connector, it's an active participant in the system's performance, responsible for efficiently distributing electrical power to each connected device and managing the constant, high-speed exchange of data that fuels the entire operation. Consequently, the capabilities and architecture of this central hub directly influence how quickly the computer can process instructions, how stable its operation is, and its overall responsiveness. The evolution of these fundamental platforms is a story of continuous innovation, driven by the ever-increasing demands for speed, power, and versatility. Early computing devices often relied on more fragmented and less integrated approaches to connect their disparate functional parts. This often meant complex, proprietary configurations that limited expandability and upgrade paths. The modern iteration, however, represents a significant leap forward born from decades of research and development. Engineers have refined manufacturing processes and adopted standardized interfaces, leading to designs that are not only more powerful, but also remarkably adaptable. These advancements have enabled the creation of models that are smaller, more energy efficient, and capable of supporting a wider array of specialized peripherals and high-performance components, all while maintaining a robust and reliable operational framework. The fundamental problem addressed by the development of this central connector was the inherent complexity of assembling a functional computing system. Without a unified and dependable platform, integrating different processing units, memory modules, storage devices, and input-output controllers would have been an exceptionally cumbersome and error-prone undertaking. Each component would have required its own specific interface and power management, leading to bulky, inefficient, and highly specialized machines. This central hub elegantly solves that challenge by providing a standardized, comprehensive framework. It offers a designated physical space for each crucial part and a robust electrical and data pathway connecting them all, ensuring that they can work in concert. This unified approach dramatically simplified assembly, improved reliability, and paved the way for the modular and upgradable personal computers we rely on today, marking a profound advancement over the more rigid and less adaptable solutions that preceded it. The motherboard, at its heart, is the central nervous system of your computer. Think of it as a bustling city map. Each component, the processor, memory, graphics card, is like a specialized district within this city. The motherboard provides the physical real estate for these districts to be built, and more importantly, the intricate network of roads and communication lines that allow them to interact and function together seamlessly. Without this city planner, the districts would be isolated and unable to share resources or information, rendering the entire operation inert. Central to this city's operation is the chipset. Imagine the chipset as the city's main traffic control center and inter-district communication hub. It manages the flow of data between the processor, memory, and other essential peripherals, ensuring that information travels efficiently and without congestion. Different chipsets have varying capacities for managing traffic, much like a city with a more advanced traffic system can handle more vehicles smoothly. This directly influences how quickly and effectively your computer can perform various tasks. For components that require their own dedicated space and direct high-speed connections, we have expansion slots. These are like building plots in our city where specialized facilities can be added, such as a powerful new concert hall graphics card, or a state-of-the-art research lab, sound card, or network adapter. The most common type you'll encounter is PCIe, Peripheral Component Interconnect Express. Think of PCIe as a super-fast multi-lane highway system. The more lanes, or lanes in PCIe terminology, the faster data can travel between the expansion card and the rest of the system, which is crucial for demanding applications like gaming or video editing. When it comes to storing your digital belongings, your photos, documents, and games, the motherboard provides interfaces for these storage devices. These are like the city's warehouses and libraries. SATA serial ATA is the current standard for connecting traditional hard drives and solid-state drives, SSDs. It's a robust, widely adopted connection that ensures reliable data transfer for your files. Newer, even faster storage solutions utilize NVMe, which leverages the PCIe highway for significantly quicker access to your data, making your system feel much snappier. Finally, the motherboard is equipped with a plethora of external connections, which are the city's gateways to the outside world. These are the USB Universal Serial Bus ports, audio jacks, Ethernet ports, and more. USB ports, for instance, are like versatile docks that can accommodate a wide range of devices, from your keyboard and mouse to external hard drives and printers. The speed of a USB port, e.g., USB 2.0, USB 3.0, USB-C, dictates how quickly data can be transferred to and from these external devices, much like the capacity of a shipping dock determines how quickly goods can be loaded or unloaded. These connections are vital for interacting with the outside world and expanding your computer's capabilities. The motherboard serves as the central nervous system of any computing device, a foundational component with profound implications for performance, stability, and future adaptability. Consider the realm of high-end gaming desktops. Here, the motherboard is meticulously chosen to accommodate the latest, most powerful graphics cards, often requiring robust power delivery systems and ample PCIe lanes to ensure these visual powerhouses operate at their peak. Similarly, the choice of memory slots directly influences the speed and capacity of RAM that can be installed. A gamer seeking to experience immersive virtual worlds with smooth frame rates will benefit immensely from a motherboard supporting faster DDR5 memory and higher total capacities, allowing for more complex game assets to be loaded simultaneously. Beyond gaming, this central hub is equally critical in the demanding environment of high-performance servers. These machines, tasked with processing vast amounts of data and supporting numerous users, rely on motherboards engineered for extreme reliability, often featuring support for multiple processors, extensive RAM configurations, and specialized network interfaces. The ability to integrate high-speed NVMe SSDs, bypassing traditional storage bottlenecks, is another significant advantage facilitated by modern motherboard designs, leading to dramatically reduced loading times and enhanced responsiveness across all applications. The tangible benefits extend to the ease of expansion and personalization. When assembling a custom PC, the motherboard acts as the canvas upon which all other components are mounted. For instance, a user wanting to upgrade their storage capacity can easily add more high-capacity SSDs or HDDs to the available SATA ports, provided the motherboard offers sufficient connections. Likewise, the desire to incorporate specialized expansion cards, such as sound cards for audio files or capture card for content creators, is directly supported by the number and type of expansion slots present on the motherboard. This modularity, inherent in the motherboard's design, allows a standard personal computer to evolve from a basic workstation into a powerful and versatile machine capable of tackling a wide array of tasks. The strategic selection of a motherboard with future-proofing in mind, perhaps featuring newer connection standards or more robust power circuitry, can significantly extend the useful lifespan of a system, allowing for gradual upgrades rather than complete overhauls. The motherboard, as the central nervous system of a personal computing device, exerts profound influences across social, economic, and ethical spheres. Its very existence and capabilities dramatically shape accessibility to digital tools, determining who can participate in the increasingly digitized global landscape. The cost and complexity of a motherboard directly correlate with the affordability of a functional computing unit, impacting educational opportunities for underprivileged communities and hindering economic advancement for those without access to these fundamental systems. Furthermore, the intricate network of components it supports dictates the device's environmental footprint, raising critical questions about sustainability. Economically, the motherboard is a linchpin. Its design and manufacturing processes involve a global supply chain, impacting employment and resource allocation. The drive for innovation within this component fuels competition, leading to both cost reduction for consumers and, conversely, the rapid obsolescence of older models. This cycle of upgrade and replacement, driven by advancements in processing power and connectivity that the motherboard enables, has significant economic implications, fostering industries dedicated to production, distribution, and repair, but also generating substantial electronic waste. Ethically, the motherboard's role in data security and privacy is paramount. The integrity of the data stored and processed within a computing system fundamentally relies on the secure architecture facilitated by its motherboard. Vulnerabilities in its design or implementation can expose sensitive personal information to malicious actors. Conversely, robust motherboard designs, incorporating secure boot processes and hardware-level encryption, can offer a foundational layer of protection, fostering trust and encouraging the widespread adoption of digital services. The benefits derived from a well-designed motherboard extend across diverse facets of human life. In education, it provides the gateway to vast repositories of knowledge, facilitating research, online learning, and collaborative projects, thereby democratizing access to information. For the professional realm, it underpins productivity tools, communication platforms, and the complex simulations essential for scientific discovery and engineering, directly enhancing work quality and efficiency. In entertainment, it powers immersive gaming experiences, high-definition media consumption, and creative content generation, enriching leisure time and fostering new forms of artistic expression, all contributing to an improved overall quality of life. However, significant concerns loom large regarding the life cycle of these essential components. The specter of planned obsolescence, where devices are engineered to have a limited lifespan, often manifests through motherboard limitations, pushing consumers towards premature replacements and exacerbating the problem of electronic waste. The improper disposal of discarded motherboards laden with hazardous materials poses a severe environmental threat, contaminating soil and water resources. Moreover, the increasing interconnectedness facilitated by advanced motherboard capabilities raises profound questions about the privacy of data, as vast amounts of personal information are collected, processed, and potentially stored, demanding stringent regulations and user awareness to safeguard individual liberties. This necessitates a critical reflection on our reliance on such systems and a commitment to more responsible and conscious engagement with the technology that underpins our modern world. The motherboard, the silent conductor of our digital orchestras, stands on the precipice of a radical transformation, driven by emergent paradigms that promise to redefine computing as we know it. Roadmaps and emerging trends paint a vivid picture of its future, where the integration of artificial intelligence, quantum computation, and the ever-expanding Internet of Things will necessitate entirely new architectural approaches. Imagine motherboards not merely as passive conduits, but as intelligent hubs capable of onboard AI processing for predictive maintenance, dynamic resource allocation, and even self-optimization based on real-time usage patterns. This shift will move beyond simply accommodating AI accelerators to embedding intelligence at the very core of the system. The burgeoning field of quantum computing, while still in its nascent stages for widespread consumer adoption, will undoubtedly influence the long-term trajectory of motherboard design. While quantum processors will likely remain specialized, their eventual integration, even in hybrid architectures, will demand novel interconnectivity solutions and specialized power management systems to handle their unique operational requirements. Furthermore, the pervasive nature of the Internet of Things will necessitate motherboards with enhanced connectivity options, improved security protocols built directly into the silicon, and a greater emphasis on energy efficiency to power a multitude of interconnected devices seamlessly. The miniaturization and increased power demands of IoT devices will push motherboard manufacturers to innovate in areas like scalable processing and secure communication interfaces. Looking beyond silicon, the exploration of novel materials holds immense potential to revolutionize motherboard performance and energy efficiency. The theoretical properties of graphene, with its exceptional conductivity and strength, could lead to faster signal transmission and more durable circuitry, potentially overcoming current limitations in heat dissipation and signal integrity. Similarly, the investigation into superconductors, even at higher operating temperatures, offers the tantalizing prospect of near-zero energy loss during data transfer, dramatically reducing power consumption and the need for extensive cooling solutions. These material advancements aren't merely incremental improvements. They represent a fundamental reimagining of the physical substrate upon which our digital world is built, paving the way for faster, more efficient, and more sustainable computing platforms. The evolution of a motherboard is not just about faster speeds. It's about a more intelligent, interconnected, and energy-conscious future, a testament to the enduring power of human ingenuity in shaping our technological landscape. Beyond the core processing and graphics power, specialized peripherals can dramatically enhance specific user experiences. For instance, a high-performance capture card is indispensable for those involved in live streaming or recording gameplay. It allows for the seamless acquisition of high-fidelity video and audio from external sources, offloading this demanding task from the CPU and GPU. This results in smoother, lag-free streams and recordings, crucial for maintaining viewer engagement in the gaming and content creation spheres. Without one, the system might struggle to encode the video feed in real time, leading to dropped frames and a compromised visual experience for the audience. Dedicated sound cards, while often overlooked in favor of integrated audio, offer a significant upgrade for audiophiles, musicians, and even competitive gamers who rely on precise audio cues. These components boast superior digital-to-analog converters, DACs, and analog-to-digital converters, ADCs, resulting in richer, more detailed sound reproduction and clearer audio input. For music production, this means capturing subtle nuances in recordings, while for gaming it can translate to pinpoint accuracy in identifying enemy footsteps or the direction of incoming fire, providing a tangible competitive edge. The clarity and depth they provide are often a revelation compared to the often compressed output of onboard audio solutions. High-performance Wi-Fi network cards are another critical, yet frequently underestimated, component, especially in an era of increased reliance on stable wireless connectivity. For gamers, a robust Wi-Fi card with low latency and high throughput minimizes ping and packet loss, ensuring a responsive online experience where milliseconds can make the difference between victory and defeat. Similarly, content creators uploading large files or collaborating in real time demand a stable and fast internet connection. These cards often support the latest Wi-Fi standards, offering significantly faster speeds and better signal penetration, thereby reducing reliance on potentially less convenient wired Ethernet connections and improving overall system responsiveness in networked activities. Consider a professional gamer. Their setup might prioritize a top-tier graphics card, a powerful CPU, and a high refresh rate monitor, but a low-latency Wi-Fi card and a dedicated sound card would be equally vital. For a content creator focusing on video editing and streaming, a powerful CPU and ample RAM are paramount, but a high-end capture card to ingest footage and a fast Wi-Fi card for uploads become essential. Even an amateur content creator could benefit immensely from a good capture card for their initial foray into streaming, allowing them to present their work with a professional polish without needing to invest in a full studio setup. These components aren't just add-ons. They are integral to tailoring a system for peak performance in specific demanding applications, ensuring that the user's hardware actively supports their passion rather than hindering it. The air flowing through a computer's enclosure plays a far more critical role than many realize. It's the unsung hero of system stability and longevity. A thoughtfully designed chassis facilitates efficient air circulation, drawing cooler ambient air in and expelling the heated air generated by powerful internal components. This constant exchange is paramount for preventing thermal throttling, a phenomenon where processors and graphics cards reduce their performance to avoid overheating. Effective airflow directly translates to cooler operating temperatures, which in turn reduces stress on delicate electronics. This not only guarantees smoother operation during demanding tasks, but also significantly extends the lifespan of the hardware by minimizing wear and tear caused by excessive heat. Beyond performance, good airflow contributes to a quieter user experience. When components are kept at optimal temperatures, fans don't need to spin at their maximum speed, drastically cutting down on noise pollution. Several cooling methodologies exist to manage internal temperatures. The most common is air cooling, which relies on heat sinks and fans to dissipate heat. Heat sinks, often made of aluminum or copper, have fins to increase surface area, while fans actively push air across them. For more demanding setups, liquid cooling offers superior thermal performance. All-in-one AIO water coolers are pre-assembled units that circulate a coolant through a block attached to the processor, a radiator, and a pump. For enthusiasts seeking ultimate control and performance, custom liquid cooling loops allow for the integration of multiple components, such as the graphics card, into the same cooling circuit, offering unparalleled temperature management and aesthetic customization. Optimizing airflow within a computer's enclosure involves several practical considerations. The strategic placement and selection of fans are crucial. Intake fans should be positioned to draw in cool air from the front or bottom of the case, while exhaust fans should be located at the rear or top to remove hot air. Cable management is another vital aspect, as a tidy interior allows for unobstructed airflow, preventing heat from getting trapped. The installation of dust filters on intake vents is essential, as accumulated dust acts as an insulator, severely hindering cooling efficiency and potentially damaging components over time. These filters need regular cleaning to maintain their effectiveness. Ultimately, a well-ventilated system represents the difference between a consistently reliable and productive user experience and one plagued by frustrating performance dips, unexpected shutdowns, and the looming threat of hardware failure. When internal temperatures are kept in check, components operate within their intended parameters, leading to a stable, responsive, and enduring personal computing environment. This careful attention to thermal management ensures that the passion for content creation or any other demanding digital pursuit is supported by hardware that performs flawlessly, allowing creativity to flow unimpeded by technical limitations. The heart of any robust digital setup lies not just in its processing power or graphical prowess, but critically in its power supply unit, PSU. A high-quality PSU is the unsung hero, directly influencing system stability and overall performance. It acts as a vital guardian, filtering out destructive voltage spikes and surges that could otherwise cripple sensitive internal hardware. By delivering a consistent and clean flow of electricity, a reliable PSU ensures that every component, from the CPU to the graphics card, receives precisely the energy it needs to operate at peak efficiency. This electrical tranquility is fundamental to preventing unpredictable behavior, stuttering performance, and ultimately, the premature failure of expensive parts. PSUs come in several configurations, each with its own advantages. Non-modular units have all their cables permanently attached, offering simplicity, but potentially leading to cable clutter within the case. Semi-modular PSUs offer a middle ground, with essential cables hardwired while others can be detached, providing a balance between ease of installation and improved airflow. Fully modular units allow for complete detachment of all cables, granting the user maximum flexibility in cable management and the ability to use custom sleeve cables for aesthetic appeal, which also contributes to better air circulation. Selecting the correct PSU involves careful consideration of several factors. Power wattage is paramount. It must be sufficient to handle the combined power draw of all components, with some headroom for future upgrades or peak loads. Efficiency ratings, often denoted by certifications like 80+ bronze, silver, gold, platinum, or titanium, indicate how much energy is wasted as heat. Higher efficiency means less wasted energy and lower electricity bills. The certification also signifies adherence to quality and safety standards, ensuring a more dependable operation. Conversely, an inadequate PSU can be a major source of system woes. Insufficient wattage can lead to immediate instability, causing random shutdowns or preventing the system from booting altogether. Poorly filtered power can manifest as graphical glitches, audio artifacts, or persistent system freezes, often making troubleshooting a nightmare. In the worst-case scenarios, a faulty or underpowered PSU can deliver unstable voltages that outright damage or destroy delicate internal components, leading to costly repairs or replacements. The foundation of a stable digital experience is, therefore, undeniably built upon a robust and appropriately chosen power supply. The digital landscape is undeniably complex, and at its core lies the motherboard, the central nervous system that orchestrates the flow of information. Paired with its essential supporting components and a diligently designed cooling system, It forms the bedrock for a potent and dependable computing environment. Understanding the intricate interplay of these elements empowers you to fine-tune your system's capabilities, circumvent superfluous expenditures, and ultimately cultivate a more enriching interaction with your digital tools. As the frontiers of innovation continually expand, the motherboard will undoubtedly persist as a crucial element in shaping the world around us. Cultivate a spirit of inquiry, embrace novel avenues of exploration, and draw inspiration from the boundless potential inherent in these advancements. Remember to subscribe to the channel for ongoing insights into system enhancements and technological upgrades. The repercussions of inadequately conditioned energy can manifest in a variety of unsettling ways. Visual distortions that flicker across your display, unwanted noise intruding upon your audio, or frustrating, recurring system lockups can transform troubleshooting into a daunting ordeal. In more severe instances, an insufficient or malfunctioning power unit can supply fluctuating electrical levels, posing a direct threat of damage or complete destruction to sensitive internal hardware, culminating in substantial repair bills or the necessity for component replacement. Consequently, the very stability of your digital operations hinges unequivocally on the presence of a solid and thoughtfully selected power delivery mechanism. As we've explored the vital role of the power supply unit in maintaining system integrity, it's crucial to acknowledge how its proper functioning directly influences the longevity and performance of every other component, especially the motherboard. A stable current ensures that the intricate pathways on the motherboard responsible for communicating with the CPU, RAM, and expansion cards operate within their design parameters. Without this consistency, even the most advanced motherboard can falter, leading to erratic behavior that is difficult to diagnose and can potentially cause cascading failures. The seamless integration of power and data management, facilitated by a high-quality PSU and a well-designed motherboard, is what allows for the smooth execution of complex tasks and the enjoyment of immersive digital experiences. This meticulous attention to detail in selecting and integrating each element, from the power source to the cooling apparatus, is what distinguishes a merely functional system from one that truly excels. It's about building a robust foundation that can not only handle current demands, but also adapt to future innovations. The journey through understanding these interconnected pieces reveals a fascinating ecosystem where every part plays a critical role. The continuous evolution of these technologies means there will always be opportunities to refine and enhance your setup. Embracing this ongoing learning process ensures that your digital capabilities remain at the cutting edge, providing a consistently rewarding and powerful experience.